Hello, I'm Nathan King, and welcome to my semester research assignment. Today, I'm going to be talking about cloud-based architecture for big data analysis, and specifically, I'm going to be talking about the data warehouse and data lake. So, for a broad run through, the data warehouse and lake are storage systems that are designed to handle massive amounts of data, specifically for data analysis and decision making. So we're going to start with the problems or limitations of the relational model in the OLTP systems, which stands for online transaction processing. So this is your typical relational model or like a SQL type model. And these typical OLTP models often store transactional data and they store the data into smaller tables by normalization. So these are not as efficient for data analysis and visualization in business intelligence because finding trends and patterns through data, like over time, they often require table joins and like some sort of aggregation, like sum or average. And when you start working with truly huge amounts of data, these joins and aggregations can take a very long time. So these are not specifically efficient for this task. So the solution to this or this limitation is the data warehouse. And as you can see, well, I'll explain that later, but the data warehouse also stores structured data like the relational model, how it's also a relational model. But unlike this relational model from before, data warehouses are not normalized. And in fact, they're typically go through a process called denormalization to make larger tables. So this would require less joins than a traditional relational model. And data is stored typically as aggregates. They're pre-aggregated. So instead of storing every single transaction, like every single sale, you would store the total amount of sales per month or per day or anything. So this specific way of doing things allows you to query faster, especially with the larger tables, since you don't have to join. So these have applications in business intelligence and data analysis, and they're primarily stored in the cloud, mainly for scalability and cost, as storing it on premise would take a lot of hardware costs. And these are also not well for suited well for unstructured data. So the solution to that would be the data lake. And these are designed to handle unstructured data, unlike data warehouses. And these have a schema on read approach, which basically just means there's no predefined schema, unlike the traditional SQL model. So as you can see, any type of data can go into the data lake, structured, semi-structured, or unstructured. And this data is not cleaned before it goes into the data lake, unlike the data warehouse. Data filtering is done after. So this often gives you cheaper storage, which allows you to store more amount of data for the same price, which is beneficial. This has applications in machine learning, scientific research, IoT, and more. And these allow storage of raw text and images, unlike data warehouses. So these are useful for machine learning. If you need natural language processing or computer vision, you can store better data. And these are almost always stored in cloud because of how massive the data lakes can get. And data warehouses and lakes are often used alongside each other, as data lakes can store the unclean data, and then once you feel like using it, you can take it out, clean it, and then store it into a data warehouse when needed.